Okay, so welcome to the CMPT 371 final exam review session. Uh, this session is geared towards preparing everyone for the final exam, but it also serves, I think, even more significantly as a chance to reflect on the uh, structure of the course and major messages emphasized within the course, major points of learning and spheres of focus. And I'm hoping to use the next 2 hours to provide insight into those topics, but also uh, equally importantly, to answer your questions. Um, Before we begin, I'll just note that I do make a point of offering these review sessions each year that I teach the course. And uh, I have sought to record those sessions each year that I teach them. You'll find online, and I believe some of you have already done so, several of these sessions. And this afternoon, or earlier today, in any case, I did take the step of providing links to recordings of recent years sections for this course, sessions for this course, and placing them on the Canvas site. So if you go to the Canvas site, you'll find, I believe it's three links to recordings on YouTube of 3 previous years final exam review sessions. And while there are some differences between those years, there are certain topics, such as software entrepreneurship, Liskov substitution principle, issues of safe subclassing beyond that principle, concerns involving testing of object-oriented systems in particular, and a set of other topics that are electively covered in each year. And often I'll sort of revisit some of those in, if not a round robin fashion, at least semi-periodically. There's a tremendous amount of commonality. And if you're interested in, securing a deeper reflection on the course contents, you'll find the coverage there largely transfers over to this semester, with a few differences that I'll try to note. Broadly, this semester I chose to experiment with or trial, placing more emphasis on class discussion. Sometimes, on a number of occasions, instead of delivering a lecture, sought to turn it into more of a back and forth discussion. And that conferred some benefits, but it had some costs as well in terms of coverage of certain topics. I could have plowed through certain the set of materials quicker and spent more time on additional topics, had that been my intention. But I erred on the side of this semester of having more fulsome exchange, etc. You'll find, therefore, some of these topics brought out in these previous sessions that I didn't cover this term, and indeed in lectures within the term for those previous years. Right. So in terms of structuring the session, beyond those remarks situating this session, my thought was to at the cost of repeating myself, revisit for those who weren't present, the question of exam structure, to then open the floor to questions that might have arisen from students, pre-existing review of the material or just confusions regarding the class, with those being a top priority. And once we're past that initial such session of fielding questions, my thought was to go through in a not a comprehensive, but a reasonably systematic and integrative sort of reflection on major themes, topics, seeking to emphasize points I think are most important, points that have a distinct chance of being featured because of their importance on the final exam. And my thought was, as time allowed, to have discussions on those issues. So please bring forward questions during that coverage. So if I mention fault feedback ratio, or I, rip through a session where I talk about separation of concerns, or comment only on passing on orthogonal arrays or something like that, or equivalence classes, you could bring these things up in the chat or verbally, and I'll seek to respond there. And then finally, again, as time allows, my plan was to field questions at the end as well. There might or might not be time for it. I will share with you that I came reasonably close to alerting you that this session was at risk, because I'm feeling pretty badly under the weather today, since I've woken up in the morning. I think I have some sort of head cold, and it's pretty bad. So I don't think that I think it's unlikely that I'll go beyond 2 hours here. But I made my commitment. I know the timing of this session is critical for providing you that chance to study, and that tomorrow was a poor time, so I stuck with the plan. But I'm not feeling great. In fact, I'm feeling pretty lousy, and I doubt I'll go beyond 2 hours. So we'll give it what we can, and you should know that with a lot of these sessions, in my systematic emphasis on things that are important, I go away, wondering if I've given away the shop in terms of exam preparation. Just shared too much, but marking the exams sadly always disabuses me of that fear, that I've been too transparent in my comments. But in short, you should carry away from this really good guidance, even with, even strictly speaking to 2 hours and the inability to cover it comprehensively. I think you'll come away with very good sense of material to expect on the exam. A very good grounded sense of what sort of things might be on the exam. Even if you don't explicitly have that, you'll know the topics that, what I mean first and foremost, that are likely to be prominent in the exam. And you'll have a sense of, things that are not in the exam and things that are very, very good candidates. Okay. So with that preface, let me comment some on exam structure. Again, the cost of repeating myself to some utterances I made, not 3 weeks thence. Um, I noted that the exam broadly includes 3 or 4 types of questions. So the first is short answer questions. These are fill in the blanks, true, false, that sort of thing. Sometimes slogans, sometimes core concepts, etc. Facts that I related, crisp facts that should be memorable enough that you can recall them in true, false context, etc. One type of question. Second type of question would be kind of medium-sized questions that might ask you to, enumerate 3 levels at which testing can be conducted, or benefits of separation of concern. Advantages peer review offers compared to testing, whatever. Those sort of things where you're asked to sort of comment in brief, very commonly enumerating a small number of points. And there are some borderline questions that sort of take that in a bit more of an essay direction, on the degree to which they might involve, present an argument that X, and it's often a situational argument. You imagine you're in this context. What would your argument be towards this point? And that sort of question verges onto an essay. There are then some longer answer questions. I won't say essays because they certainly ain't essays. That pose challenges to you and require analysis and systematic answering on some crisp challenge of various sorts. And I'm looking for answers of a certain specific sort that demonstrate good thinking about the challenge at hand. And if you think about it, I'm not gonna show my cards. Sorry, I'm gonna ask my wife to. So hold on for a second. The background noise is getting a bit high. Yeah. Okay. Anyway, so these are somewhat longer answer questions. Not yeah. Because they ask you to undertake a challenge, and those challenges have been found in a number of specific areas within the class, and I'll ask you to undertake those challenges. And you got to watch out in terms of your traversal of the exam, because those will often take some significant time and are rewarded by significant points. And then fourthly, there's a type of, you could say, question, sometimes they're required, that seek to elicit from you information important for assessing the role that you and others played in the course of the project, and the contributions made in that context. And as I've noted in class, there are optional point, or there's those are not 4 points. Um, and also I'll provide an opportunity for you to provide your own perspective in terms of reflection and postmortem, in a page or so, if you'd like to do so. I'm not using it as a contribution of your mark, but it may be that the group postmortem provided a broader consensus or group view on the situation, and you want to provide some comments of your own. And I would welcome that. I read those carefully. Um, and but they're not, mark allocation relevant. So this fourth type of question does not involve conferring of marks, but it does involve communicating to me important pieces of information that can help me understand your contributions and the team's contributions, etc. So contributions across the team. Yeah, so those are some comments on sort of question types. If I had to give 1 point of sort of procedural advice when taking the exam, it would probably be pace yourself. Recognize that you can return to a question later, and you may want to put down a quick initial answer and come back. And you can, within the exam taking software, flag it to yourself so that you can come back, remember, where it was located, so you can come back and answer it to your satisfaction. It's just I'm currently in the midst of dealing with a first draft and whittling it down to try to lower the proportion of people that feel unable to finish it within the time. I don't like leaving people hanging, unable to answer questions just because they haven't moved through all of it. And I'm sort of, carving away little bits here and there. And I need you on your side to remember to pace yourself and don't get too caught up, and spend half the exam in one question, when it's only worth, a fraction of the mark of the exam. That being said, if I had to think off the top of my head right now, there are I'm not sure that there are any questions worth more individually, like that question is a fraction of the total, more than like 6 or 7% of the exam. So in other words, if you don't have to worry there's a question that by itself is worth 20% of the exam. Nothing of that sort at all. There are some longer ones, but they're not, and they carry more weight, perhaps 10 points instead of 2 or 4, but it's not like they carry, 40 points or something like that. So just remember that in your traversal through the exam. Pace yourself, try to get through there, longitudinally, so that you can go back and spend time having given a first decent cut at the questions in the full length of the exam. It will take some care. Okay, so Just one or two other things, I guess. I mentioned the sort of flagging questions for yourself. Um, that's important, but also when you go to, you'll be navigating between pages for different questions. And when you're done with the exam, you'll be able to go back and forth between questions. When you're done with the exam, be sure to press submit. It will happen automatically after the allocated time. It should, but don't leave it a chance. Make sure you press submit and make sure you sign the tally sheet at the front of the room. I'll be there. I'll be circulating them between the rooms uh, to make sure questions answered in one room are the answers are conveyed in other rooms. Good, good. Those are some high-level comments on exam structure. Uh, I now welcome a first round of questions from students. What topics, what challenges or issues or confusions would you like me to address right now? Are there any that stand out? Okay. Um, can I repeat? Are you required to answer the fourth type of question? Um, you you so those so I can understand your confusion, Jason. So Jason was asked about this fourth type of question, which is at once important, provides me important information. I even uttered in passing that it's some of them, not all, are required. But I also said at the same time that they're not conferring marks. So what's up with that? Well, what's up is that I'm trying to keep it fair, but at the same time, I'm trying to make sure that I secure the information needed to recognize people for the efforts they put in and the diversity of contributions people have made in your projects. And and so while there are some questions there that are marked as mandatory, um, they don't confer marks. Um, and if you want to put it in the baldest of terms, uh, will you fail if you don't answer those? No, I'm not going to fail you for not answering a mandatory question that confers no marks. I'll be kind of disappointed because I want to give people due credit. I want to understand people's contributions. I want to understand the perspective of others on the contributions across the projects. So I need that information, and I would urge you to take the couple minutes it takes to answer the mandatory questions there. But no, they're not going to lead to you to have points deducted, marks deducted, and you're certainly not going to fail through having not, answered those questions. It's just, if at all possible, try to answer those, recognize those are important. Don't just leave them blank gratuitously, because they're really important. But no, I'm not gonna ding you marks because you're too busy. You 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 lost track of time and you're not able to answer them before the end. Just try not to do it. Don't treat them casually. Try not to do it needlessly. Yeah. Hope that's helpful. Okay, other questions though. That was a good one. Questions on material, questions on exam, questions on the kind of the process you'll be going through, on scope of the exam.
Is there any chance that we could go over maybe some example questions that would be appearing on the exam, something like that along those lines?
You already have. They're called pop quizzes.
Is it in the pop quizzes? All right.
Well, I mean, yeah, I when handing out pop quizzes and when collecting them, I think I noted that there's a high overlap between what's on of the sort of questions on the pop quizzes and what's on the exam. So now, clearly, you could argue that the pop quizzes are a small sample size. In this term, that's true. I have been known to deliver pop quizzes every class or every other class. For most classes in some semesters of 371. Um, this term they were not very numerous, but broadly uh, those are indicative of the first two classes of questions. Uh, Short answer, true, false, fill in the blank, and sort of, mention three benefits that use of assertions offer um within a program. Mention two types of bad situations that assertions should not be used to flag, or what have you, of problems that assertions should not be used to flag. Um, those sort of questions. Those are the sort of thing which I would test on the pop quizzes. Now, beyond those pop quizzes, we had some take-home exercises. I asked you to try things, and those are fair game for some of the longer questions. So between those, I think you have a sampling of issues from the final exam, of things from the final exam.
Thank you.
Yep. Okay, there's a question about orthogonal arrays. I'd be delighted to go over orthogonal arrays. So let me pull out my bag of tricks and we'll get going. Right. Okay. Here we go. Yeah. Okay. So I'm going to share my screen here. So broadly, orthogonal arrays fall into the theme or topic within the course of test case design, of judicious design of test cases. And they're not alone in that regard. There's actually a variety of specific techniques that we have explored either more briefly towards the end or with reference during the semester for test case design. They include using equivalence classes, thinking about kind of groupings of inputs or situations into groups that elicit similar errors or results or types of answers. And testing at least one representative for each of them. They included boundary value choices where things will sometimes fall between classes of of these sorts. So maybe there's the first class cabin and the economy cabin, and a boundary would be a seat right between the the first the last one in business class, or the first seat as you go into the plane that's in economy class. We talked about using specifications where you have preconditions and postconditions, for example, to test functions, or sometimes your goal is to make sure that it handles test cases that are allowed as preconditions. And in other cases, depending on your development philosophy, whether you believe, violated preconditions are errors to be handled explicitly, you might test, violations of said preconditions in defined ways. I also asked you to watch a video on coverage testing, which helps you choose a judiciously chosen set of test cases. For example, test cases that will allow you to hit to make sure the system has been checked in all the different states it could be in, say for an automated teller machine where you withdraw cash from a bank, or a travel reservation system where you can be in different specific states. Another type of coverage testing tests transitions, say between screens, like in your UI flow diagrams. You not only want to reach each possible screen or possible point you can be in the application with certain dialogues being shown or what have you, but there are different ways of going from one screen to another, for example, and you want to test those different ways of going. So all these are about choosing test cases thoughtfully, but it's not just thoughtfully, it's choosing them according to the principle of bang for the buck, getting more from your limited test time. Given that our testing time is limited, it behooves us to test intelligently things that are more likely to show a problem. And if there are problems out there, they may well be a problem with how it handles a boundary case, an edge case, right? Or how it handles a certain error type. That's sort of why we pick a representative of that equivalence class. And orthogonal arrays fall right into this motivation, okay? So orthogonal arrays are motivated by an observation that when errors come within systems, if they're not because the system has just a single input in a single equivalence class or boundary value where it fails, it's because if it's not something like that, often the next most common situation is it fails because of a combination of situations. It's not just one by itself that's enough to elicit the failure. It's a pair of these situations. And this can occur at the level of a function receiving different arguments. For example, it may be that the function, if it takes two arguments, maybe it handles it properly if both the arguments are non-null. or if both are null. But if one is null and the other isn't, maybe then it gets into trouble. And so it's not a matter that it works always if the first argument is null, or it doesn't work always if the first argument is null, or if the second argument, it requires a specific, a combination of circumstances between the two inputs. So you can't sort of pick for a given input in isolation of thinking about the other. You can't just say, well, we'll test it with all possible inputs for the first argument and all possible inputs for the second argument, and then we're done. No, you have to test combinations. And this is where combinatorial explosions would normally come in. So, one area where this comes up quite a bit is if you're testing configurations of systems. This is an old slide, but the point transcends time. And it has to do with, the fact that sometimes you have different types of software that need to play together. So maybe you have an operating system for a server, you have a browser, and you have possible plugins where a given plugin could exist with different browsers, and different browsers could exist with different server types and different operating systems. And one of the key realizations is here that sometimes you don't have the luxury of spending the time considering all possible combinations. So here for browser, if you have three combinations, here in Netscape IE and Opera, and you have four different plugin possibilities, and you have, three different server types, well, and then three different types of operating systems, you're dealing with a combinatorial explosion. The set of all possible combinations of all these things is going to be 3 times 4, that's 12, times 3, that's 36. And then once again, times 3, it looks like. So that's going to be like 108. Excuse me. Yes, 108. Yeah. So, that may be prohibitively large number of possibilities to configure for a system, right? To try your system out on all these different possible configurations. So what orthogonal arrays zero in on, look, let's not, okay, if we don't have time to examine all possible combinations of these, let's focus on the issue that's most likely to be a problem. So if there is a problem, if it's not that it just never works with Netscape at all, or never works with Opera at all, if your system works with Opera, works with Netscape, and if it works with each of the real media players in some system, and server and operating system underlying it, maybe the problem is instead, often the problem is instead pairwise incompatibility. So the problem isn't that it doesn't work with Opera. The problem is it doesn't work with Opera with real player, the media player that was prevalent then. So it's that pairwise combination. Or maybe the issue is not, a browser and plugin, but instead it's a matter of, the real player just does not work with Apache. These are pairwise incompatibility issues. It doesn't cut it for these to test with all browsers not worrying about the plugins, test with all plugins, not worrying about browsers or servers or operating system, test with every server, and just declare victory. No, because there may be a pairwise incompatibility. There's a lot of things in life where we have this, right? Maybe Vite doesn't play nicely with a certain logging framework, right? And the problem isn't Vite in and of itself is broken per se. It isn't that that logging framework can't be used. It's that they don't play nicely together. And there's many cases where this is the case. If we have, if we have functions, the same thing can occur. That maybe the problem isn't that it breaks when str is null, definitively. Maybe the issue is str is null by itself doesn't cause it to break, but maybe it breaks if str is null and you have a situation where start and final are not -1. So if someone tested this with str null and start and final being -1, it wouldn't show a problem. You might be tempted to declare victory, but instead it's a pairwise issue. It's not this in isolation. It's this together with what the value, let's say, is of start. And the same thing with this. Again, I said like maybe it works if if you test it with this being null and you don't worry about that, maybe it works. You test it with this being null and you don't worry about that, meaning maybe you say this is null. What the heck? We'll just make this null. Okay, it works. Now we'll make this null and we'll make this null as well. Does it work? Yeah, sure. Okay. You declare victory, but maybe that's not revealing a problem. Maybe you'd find that there is a problem if this is null and this is not null, for example, and you didn't even test that because you were focused on each in isolation. So when you have these pairwise incompatibility things, or these things where you have to consider more than one component, it doesn't cut it to just say, oh, we tested our system with Netscape, we tested with IE, we tested with Opera. Or here we tested it with this being null and we tested with it non-null, and we tested with this being null and this non-null. You can't do that because you miss these pairwise issues that force you to go beyond thinking about testing with each of these in isolation, and you have to consider pairs of them. So orthogonal arrays is about pairwise testing. And the key thing is that it avoids the need, this is critical, it avoids the need to consider all possible combinations, which is often prohibitive. Instead, what it enumerates, what it guarantees, is that for any pair of columns you choose, let's say browser and plugin initially, every pair of values is tried between the values. So we not only have Netscape, tried sometimes we've tested Netscape with each of the plugins. We've tested IE with each of the plugins. We've tested Opera with each of these plugins. But more than that, we've tested each browser with each server as well. So Netscape has been tried with each server. IE has been tried with each server. So if there's an incompatibility where, Netscape doesn't play nicely with Apache, you would show it. And that would have been shown in examining all combinations, but this is going to allow us to do it much more cheaply. Similarly, Netscape, you test Netscape with all of the possible operating systems as well. Now notice that there are 108 combinations, right? If I said 4 times 3, it looks like maybe it's 3. Okay, 3. I guess it's only 3. Yeah, so it's 3 to the 4th, right? Which is 81. 81 combinations naively if I examine all possible combinations. But I'm not doing that here. For an orthogonal array, I'm examining just a total of 9 combinations. 9 combinations. I've tested all possible pairwise combinations. And that's, browser with plugin, browser with server, browser with operating system, plugin with browser, yeah, plugin with server, plugin with operating system, server with all the previous ones, server with operating system. I've tested all pairwise combinations. That does not mean I've tested all possible combinations, of these four. For example, here I've tested Netscape with Real Player and Apache and Windows NT. I've not tested Netscape with Real Player. Well, I have tested that pair. That's what's guaranteed. There's at least one pair of Netscape with Real Player. That doesn't mean I've tested Netscape with Real Player with every possible operating system. No, 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 no. I'm not making that promise. What I in an orthogonal array am guaranteeing is that each combination of two, each pairwise, for any two fields here, for any two columns, I've tested that pair. And that allows me to do this testing in a vastly smaller set of possibilities, 9 compared to 81, right? 1/9 the number of possibilities. So we are testing every pair of variable values. Every pair of variable values is guaranteed to be tested at least once. But we're doing so with vastly fewer possibilities. So uh, if this were to take another example, if we had 5 possibilities for each variable 1, variable 2, variable 3, to do so exhaustively would require 5 times 5 times 5. Testing all pair values allows us to test all pairs of these, of variable 1 and variable 2, while at the same time getting in pairs for variable 1 and variable 3, right? And variable 2 and variable 3. And so by being clever about it and generating an orthogonal array, you test all possible pairs of these, variable 1 and variable 2, all pairs have been handled. Variable 2 and variable 3, all pairs have been handled. Variable 1 and variable 3, all pairs. But I've done so within just 25 test cases rather than 125. Um, another example here. So orthogonal arrays can involve massive reductions in your number of test cases that you are focused on. You give up exhaustive testing, which is generally not possible anyway, um, because of the magnitudes involved, and you get out a vastly smaller number that guarantee the essential property that you've tested all possible pairs of values for any two so-called variables or columns. And this reflects the value of that comes from the fact that we head off the compatibility problems that often bedevil our systems, where it's not a problem of just one thing by itself. It's not a problem of this other thing by itself. It's the problem that they don't play together nicely. Is that helpful? Okay. Okay. Yeah. So it's a way of vastly decreasing your testing number of test cases while still guaranteeing that you hit the most important test cases, namely that you've thoroughly explored, ruled out pairwise incompatibility cases where just this does not play nicely with that. Okay, other questions? Yeah, I'll post the slides. Um, Liskov substitution principle. Sure, I can do that, although I will note that within 371, oh, not the syllabus, that's not what we want. Within the lecture slides area, under Liskov substitution principle, there are large numbers of answered questions here about whether things are legitimate subtypes. And in other cases, I don't explicitly say, but I do. And in some cases, I do. Occasionally, I don't. But I will in the recording of that class, you should be able to find my comments. So those are a set of examples already posted. So I think I'm just going to leave those and refer you to that. Okay. Other questions? Yes, I will post the slides from this session. Thanks. Questions? Other questions?
Sorry, this is Rob again. I just had one other question. I remember it was on, I think it was the second pop quiz, and it was the slogan, and it was either failure or problem. Can you just repeat that one? I know it's in the notes. I
Sure.
haven't got to that part yet, but and I have it on the paper. I'm just wondering if you could just go over that idea again.
Sure. There's many slogans that I conveyed in this course. And I said if you don't attack risks, risks will aggressively attack you. Today's risks are tomorrow's problems, so you have to deal with them. But fortunately, today's problems are tomorrow's risks, so we can learn from problems that have occurred to head off risks in the future. But one of the slogans that was of great significance, and which I repeated early and often in this course, was concerned the fact that testing finds failures, peer review finds faults. And I'd like to make sure my terminology is clear there. So the idea is that when we test a system, we're testing whether its observable behavior matches our expectations, right? In some cases, it can be whether it matches formal requirements, whether you get the right answer as from the system behavior, whether it gives the right error message, right? Now, if you fail to see that, we call it a failure. But I'd accept other words for that. I mean, you could call it a system trouble incident. But it's a situation where the system is not behaving as we expect it to. Now, putting aside the important fact that some of the expectations may be wrong, when we see that, we might say, "Oh, we're reporting a defect," but technically, we're reporting a failure that suggests that there is a defect. And there's a process known as debugging, which is needed to go from the occurrence of that failure, of that mismatch between what we expect and what we see on the one hand, to go from that to find a problem in the system that gave rise to it, find the fault that gives rise to that. So maybe you don't see the error message you expect. Maybe it crashes instead. That's not the behavior you expected. Or maybe you see a different error message, which is not correct. Or maybe you see it attempt to, it just ignores the error and gives an answer which is meaningless. Or maybe it hangs, right? Freezes. These are not themselves, they don't themselves indicate the underlying fault that gave rise to that. There's presumably some faults, there's some incorrect code, or perhaps more deeply, there's a problem with the design of the system that led it, the protocol between the front end and back end to ignore the ability to transmit an error condition or what have you. Or maybe, the design of the database interface doesn't allow passing up information about errors that occurred, in the database operation. The point is, though, that when there's a mismatch between the observed behavior on the one hand and the expected behavior on the other, it doesn't immediately clue you into the underlying problem, what we call the fault. And that's why I'm using fault, the underlying problem. You could use the term underlying problem if you want to be, if that makes you feel that it's clear, and I'd welcome that. Peer review, by contrast, if we're going over a design or we're going over an architectural description of the API between the database layer, the data layer, and the business logic layer, we might notice, for example, that there's no way for it to indicate an error condition having occurred with respect to the database. Or you may be going over code involving a processing of items in a data structure, and you notice that it's failing to handle some case where there's a duplicate, or what have you. And it fails to handle a case where the value isn't, it fails to handle the case where the string is not found within a table. That there you're noticing the underlying problem, the fault. You're noticing a failure of reasoning, and that allows you to fix the problem more or less immediately. So testing finds failures means testing finds indications of a problem, symptoms of a problem, manifestations of a problem. And then to find the actual problem that gave rise to it, you need to dig down with debugging. By contrast, peer review can find faults, the underlying problem. And that can head off the need to spend long hours in debugging, trying to reproduce the problem, trying to understand the nature of the problem as described by the reporter of a system trouble incident, as is commonly required when you report a defect. You're actually reporting a symptom of a defect, etc. Yeah. Is that helpful?
Yeah, it is. Thank you very much, Professor.
Okay,
Very
sure.
clear. Thank you.
Yeah. So there's a question from one student about security testing, how to test security or any topic regarding this. No, I'm not planning. That was not part of the coverage of this class, and I'm not planning to ask questions about it on the exam. I don't think it would be fair to uh, consider that as part of the exam because it was not part of my comments within the course. The topic of secure software engineering um, is an important one. It is one that is probably covered at some level or touched on at some level in the computer security course taught by Professor Stakhanova. It differs markedly by like the set of considerations there differ dramatically by different types of software that you're dealing with. If you are dealing with apps on smartphones, if you're dealing with embedded systems, and certainly if you're dealing with security with web-based systems, if you're dealing with systems that have strong privacy constraints, these are, have different considerations associated with them. You also have, depending on the context, very different threat models that apply. You may have, insider attempts to break into a system versus for those public-facing systems, attempts from outside an organization. You can have denial of service attacks and different, man in the middle type attacks, attacks associated with where attempts are made to breach into a system and secure information versus attempts to actually, compromise the system from then on. So there's a whole world for this. And this course does not really have the option of going into these topics in detail. It does not require this as a prerequisite, coverage of security matters. And the opportunity cost is just too large to discuss this within the course. There are big considerations here, and I would refer interested parties to Professor Stakhanova's course as a good start, and to volumes that you will find on software engineering, in particular subdomains such as web application design, which may allow you to start thinking about how to take on these issues from a software engineering lens. Okay, other questions from people? These are great questions. So others.
I guess I posted a question to the chat, but I was interested in what topics would you have liked to have covered in this course that you didn't cover? And I did read the syllabus where it mentioned some of the topics where if we had time.
Yeah.
Particularly, I would be interested if you have anything to say about the software entrepreneurship aspects, but I'd like to even just have an overview of, what topics did we not have that you wish that we were able to do?
Yeah, it's a good question. There's actually, I mean, there's a smaller set where I have material on them, and in various years I deploy it as elective modules. By elective, I mean year to year I elect to roll it out or not, depending on student projects, interests, etc. And then there's others where I feel it's sorely needed, and I I would love to cover it, but I often feel that it needs coverage in other courses. Um, like a whole new course. I would say, some of them that are more in my mind. Software entrepreneurship is a often covered in 2 or 3 lecture module that I like giving. And that exposes students to issues that come in at the intersection of software engineering, business models, and um, pricing models, pricing mechanisms, metering, etc. Different types of models for value delivery, infrastructure as a service, platform as a service, software as a service, etc. Um, I also talk there some about the ways in which the software design components uh, intercept with needs of business development um, in some ways that are familiar to you, like minimal viable products, uh, but also some other ways involving the unique role that first customers play, etc. Like in the security area, this is and the security concerns. This is a somewhat challenging um, uh, topic to take on in just 2 or 3 lectures because the business models um, differ quite notably in terms of their um, implications for software engineering and the considerations uh, uh, for sort of providing guidelines. So custom development versus semi-custom development versus service delivery through websites versus working in something like infrastructure as a service, etc. It's quite different sort of risk profiles, business development models. I should put in semi-custom softwares is a key point of interest as well. And each of these has kind of different needs from a software engineering standpoint that are actually quite fascinating. And I speak as a multi-time software entrepreneur. So yes, Marzia mentions the programs for entrepreneurship, and both with Edward School of Business and the School of Engineering have this. My point, though, what I found is when I look to elsewhere around campus, um, I found, particularly for the Edwards offerings, a uh, a failure um, to fully articulate um, the considerations that come in with software entrepreneurship, because entrepreneurship is very different for different fields. If you're doing biotech entrepreneurship versus with big chemical reactor capital investments needed, etc., or if you're doing entrepreneurship related to agricultural industries, or you're doing entrepreneurship related to transportation and logistics, um, versus hardware development for computational hardware, developing drones or devices, etc. Medical devices, a whole nother area. But in software is one of these areas where there are lower capital investment requirements, and there remains a certain amount of nimbleness, a certain agility that can be undertaken in the context of software development that is very unlike what you see in some of these other areas. And I did feel in developing that module the need to speak to software entrepreneurship because of its very different capital requirements, different levels of costs that are associated with it, very different growth potential, etc. Um, and I think if one carries an understanding of these issues with software entrepreneurship um, into engagement with some of the structures on campus for business development and so on, one can be particularly well off in terms of going into an entrepreneurial direction with software. If one doesn't have that grounding for software, often you end up rediscovering some of these considerations that that really can be made up front to equip students for navigating in a more entrepreneurial direction. But beyond that, there's some really interesting work associated with expanding on discussion of safe subtyping and polymorphism towards safe subclassing and using inheritance particularly safely within software. And there is some um, wonderfully important guidelines that can come in with how to use subclassing in a manner that's safe and high leverage. Uh, that is that can be added on to what we saw for subtyping and that discusses issues contemporary software development tools like use of traits, for example. Another topic uh, which is also something that I would very much like to cover is on the area of, and I'm seeing things going back and forth here. Uh, uh, is the topic of uh, getting in place good debugging skills for students. I find that students differ markedly in terms of their ability to navigate error messages and zero in on underlying defects within this. And unfortunately, there's not a course in our program which really provides students um, the uh, the guidance and approaches towards systematic debugging that can markedly speed people's ability to read a problem and zero in on a cause for it. And that's something that I've also sometimes sought to develop. Another component, module wise, would be a greater emphasis on test-driven development um, and adherence to test-driven development processes more rigorously. Um, and conversely, uh, contract-based design, um, design by contract, where we use specifications and at an architectural and design level as needed to um, to pre-plan out our software's sort of our contracts within our software, so that we can more effectively build software that's nimble in the way it needs to, that's flexible in the areas that it needs to, but has certain guarantees in other areas. So those are some topics that I would love to cover more, but there wasn't time. I guess one final one, which is more on the human theater side, managing difficult projects and handling the human factor side of it. Sometimes I talk about project dynamics. This is a module I sometimes feature where we speak about uh, how decision making with respect to projects um, can uh, can shape the evolution of those projects in very um, profound ways, and can lead to projects going from a very favorable state to getting mired in a kind of locked in state where you have low quality, low morale, dropout, um, inability to keep confidence of customers, and you're thrashing. By contrast, good gelled teams often, and by the way, often that comes along with need for documentation because you lose people at such a rate, and people burn out and will often leave the project for those reasons. By contrast, in gelled projects, you have often extremely high morale, low documentation needed because you have low turnover, higher project quality, and that reflects that morale and a certain pride in one's craft. You have satisfied customers and good team retention that allow the team to thrive. And what differentiates those two is often expectation setting and good managerial decision making, particularly in response to adversity. So I'd like to sometimes talk about that. Okay, go over requirement solicitation. Yeah, so requirement solicitation um, is one of the absolutely um, central factors that allows teams to thrive or fail. Effectiveness and requirement solicitation. It can be the source of um, misunderstandings that lead to massive loss of work and opportunity, and at the same time, it can be um, the source of clarity that allows the team to move forward. Put bluntly, if you want to get where you want to go, you need to know where you want to go first, and be clear about where you want to go. And requirements help make sure that where you want to go is where your customer or your client wants to go. So I'm gonna share my screen here. With requirement solicitation, I want you to be aware of the key role requirements play in aiding all corners of the so-called ion triangle. Perhaps it was our first day of class that we spoke about the iron triangle. Perhaps it was our second. But the iron triangle has, you may recall, on its corners, time on the one hand, money or dollars required. And then the other corner is sometimes taken as scope, sometimes as value delivered, but quality factors end up helping on all fronts. They help lower the amount of time it takes because you don't have to do as much rework. the amount of money it takes, because often you're not paying people for as long a development period. You're not, having to redo work that you've already paid for. And in terms of scope, you can accomplish more with good quality. Quality is sometimes said to pay for itself. And it saves time. It requires investment, but it saves time in terms of, lower time spent debugging, lower time spent, retesting a system that isn't converging, uh, less time spent, making a best guess of how to fix something in really confusing code, only to find out that it was off later. And requirements are one of these factors. Getting requirements right is a factor which aids directly in quality and which can help on all three of those sides of the iron triangle. So, we talked about requirements are criteria that have to be satisfied for successful project completion. They can be functional in nature, like functionality, features, the ability to do something, right? But it can also be non-functional. It can involve response time of the system, uptime of the system, right? Availability, matters of reliability. It can involve some sort of quality of service guarantees, the throughput of the system, even potentially. But requirements gathering, requirements elicitation is this attempt to discover, what product is desired by people, what would be success for this product. And perhaps I have two foremost goals in discussing the requirements. One is to motivate just a recognition of the need to take it seriously. It's very easy for us to flatter ourselves as software developers, to think we get what the customer wants. I've seen this happen many times, that the developers are a bit smug and they think they know what's needed, only to understand later that actually their understanding was subtly or even glaringly different from what the customer really meant to convey. And there's lost time, lost opportunities, discoordination that comes about for it. Part of the team understanding the updated requirement, the clarified requirement, part still not, it isn't communicated fully, and there's work being done at cross purposes, etc. So I want to motivate an understanding the appreciation of the importance of requirements, but also to provide some tips for eliciting these more reliable. Okay. And in terms of tips, I wanted to highlight, certain ways that requirements can go wrong. Ambiguity, incompleteness, inability to recall, misunderstanding at the time, and a conflict. And by conflict, I mean different stakeholders. So for the team that's working on project one, maybe it's Wade says one thing and I said the other. There's perhaps conflict between the desires expressed by different stakeholders. And sometimes, developers get their own pet ideas. This happens shockingly frequently in my experience. They think, oh, wow, I really understand, but we can do it better than that. What they really want is this. And sometimes they're on the mark, but all too often they're grossly off themselves, or they're somewhat off. And, part of the problem here that I tried to convey is that often the client doesn't fully know what they want, and they need to see some envisioning to help them advance their understanding, and need some guidance as to what's feasible, what's not feasible, what's plausible. And the developer team also needs to, understand more deeply what the need is in that domain area, and what alternatives are available now, and what their gaps are, what the real problem is that is driving this need. Now, I could go into this much more detail, but we don't have time to talk about the specifics. I'm just going to recall for you a few key points here. Tips. So I'll mention 3 in the interest of time, because there's other questions in the chat. When you're eliciting requirements, write them down in your own words and pass them by the stakeholder and ask, have you basically expressed the requirement? Is there anything you're missing? Have you distorted anything about it? Secondly, when you're in the presence of the stakeholder, repeat back what you're hearing in your own words. Restate it in terms that express it using terms that are common to you and can be understood by the stakeholder, and assess, with the stakeholder whether you've captured it properly. You can also, at the most basic level, ask the stakeholder to rephrase it or restate it in a new way. One of the biggest challenges here is that, and I've seen it again and again, is that software engineers often take a word used by the stakeholder and believe they understand what it means based on its vernacular, its kind of common meaning as they understand it. But they don't realize the stakeholder is often using a quite specialized word. For their field, this means something very particular, and it may be very different from what it means in your area. And you need to have the stakeholder sometimes use different words, or use your own words and ask them if you've understood it properly. And you've got to spend time learning how they use those words. So I've given some suggestions there, some tips, some motivation. Those are all I'm going to give right now. But, I would remind you that you should have videos of me online from this semester, maybe, certainly from past semesters, giving a walkthrough on this. And you should be able to find that if you're interested in going into more detail. But you want to write down requirements, and you want to recognize, this is key. This is very, very important. There's a distinction between explicitly user stated requirements and derived requirements. Often the derived requirements are far more numerous than the user stated requirements. User stated requirements are requirements that they articulate, that they state explicitly, that are on their mind. But from those come often many implications for building that functionality or that set of requirements, functional and non-functional, in today's technology. So when a stakeholder makes a request, they don't generally understand the technical ramifications, where it needs to live, what protocols are needed, how one would build it, where the computation would take place, where the storage would take place. We as software engineers need to help lead them through that. But even more importantly, even more proximally, we need to understand the implications of this for the technologies involved. Because often what the user is requesting has numerous implications they don't realize in terms of the technology. So they may be asking about using AI to listen to the voice of the person speaking and to extract major themes from it. And you're going to be thinking as a technologist, like, okay, so where would that computation take place? Are we using off-the-shelf pre-trained transformer models, like large language models that are available off the shelf, or are we building our own? Is that running on the smartphone? Are we streaming data off for audio to allow a server to process this? Does it have to occur live, or can occur after the fact, like during later processing? And generally when the stakeholder's speaking or in successive engagements of the stakeholder, you're going to have to be thinking, what is the implication for this, and what things do I need to clarify? For example, is there a need to understand these topics during the conversation live in real time, or can that be done post hoc? In other words, can be done after the conversation is done. That might have very big implications for processing, the scheduling of the processing. And you're going to be thinking about, okay, can this occur on a mobile device, or more likely, does it have to get to the server? Is there a privacy issue with streaming audio off to a server? And you have to help the user, the requester, the customer, navigate the implications of these things, because they may put in a request for a requirement without understanding that it has huge implications in terms of cost, complexity, logistics, human resources, expertise, technologies, without realizing that, this thing that was just a one-off idea they had at the time has all this implication. Maybe they say, oh, well, don't worry about it then. On the other hand, maybe there's some core needs which also have big implications, or that you have to help them navigate the choices for dealing with those. Either you need it like this or that or that, and give them the help them walk through these choices. For example, are they satisfied having this information just stored on the phone? So if the user loses their phone, or the phone is damaged, or the phone is out of electricity, they can't get access to that information. If the phone is lost, they lose that information. Are they okay with that? If not, it needs to live on a server, like, that's not on the phone, and it needs to somehow sync with the server, right? Do they want to allow people to use different devices in the course of a day, or even simultaneously, to access this information? That blows open, if so, a variety of needs in terms of synchronization of different devices, etc. Or are they willing to allow it to only at any one time one device. In any case, you get the point that user requests generally are made in ignorance of the implications in terms of resources. And it's incumbent upon us as software engineers to work with the stakeholders as part of this requirement solicitation to bring them up to speed and ask what they really want, because their stated requirements may be small compared to the derived requirements, the implied requirements needed to realize that vision. Okay, so that's what I'll comment on requirement solicitation. Testing types and multi-level testing. Sure. So, I don't know how many times you've seen these, yes, Connor's asking a question. Yes, I teach that. I mean, I've taught it a lot more since 2019, but that was 1 year. That was probably the second year I taught it. But yes, I teach that. I teach many boot camps, and have taught them around the world. Probably 50 around the world for certain types of boot camps alone. U.S., Australia, Canada, Singapore. So yeah, I teach boot camps. Well, if so I could point you to YouTube playlists online. Okay, but let's address the question that came in on testing types. So you've seen this V model of testing many times, and relevant it is to the final exam. So, we've talked in this class about many different classification schemes we can use for tests. One of them is emphasized here. It's not the only one, nor the only one that is subject to being tested on the final exam, but this is a very useful one. And it characterized kind of the level of test and relates it to levels of design or implementation within our systems, with the general observation being that unit tests on small components, often mirror a level of attention that is the subject of low-level design focus. Integration tests seek to help understanding how different components of design play together, how they work together, how they cooperate to accomplish some task. And somewhere in between here is unit integration testing. Strict unit tests are quite circumscribed, because often, not always, pieces of our implementation depend on one another. So a given area of code will call off to different areas of a system. Maybe, the business logic layer, a given operation will call off to different requests within the business logic layer, and those will call off in turn, in some cases, to other things in business logic, get down to the data layer. And so a given piece of this system will often make use of different, calling off to different other elements of the system. And in strict unit testing, your focus is on that piece itself, and you will often mock out, stub out, or put in place fakes for the things that on which it calls, so you can focus in on testing that thing in isolation. By contrast, unit integration testing would test that component together with the other things that it calls, that it depends on. And in this class, I consider this class a very basic class in sort of software engineering and software development. We don't really go into, I'm not really picky or demanding of students about distinguishing when they say the right unit test. Is it really a unit test or is it a unit integration test? Because often you'll find what they claim is a unit test is a unit integration test. And a unit test is testing that thing in isolation. A unit integration test would be testing it with its dependencies, things on which it depends. An integration test, the goal of it there is how things play together nicely. At the unit integration level, your interest is still in like component A. Yes, you're testing it and it's using components B, C, and D as part of that, but really your focus is testing A. Strict unit test, you're testing A in isolation because you've mocked out B, C, D. In integration test, your goal is often how do different, it is in general, what makes it an integration test. You're seeing how things integrate together, how D and C play together, their cooperation to accomplish some task. So those are small pieces of a system. Maybe it's, two classes of a system, etc. Or two layers of a system cooperating, the business logic layer and the data layer. Should know your layers. And then system tests are testing the system often through a whole series of steps, use cases or user stories that require successive features to be used over time. So undertaking user meaningful tasks, for example. Now, this is one set of testing types, but I differentiated this with you in several different ways. One of them is shown in red there. I'm not talking here about regression tests. And regression tests are extremely important. Highly, I might add, highly examinable. Make sure there's a regression test question. So with regression tests, we are interested in ensuring the system hasn't regressed. And this comes in two main forms. Form one, that a feature that has been working, a bit of functionality that has been working, ceases to work. The second form comes in the role of defects that were previously fixed resurface as defects. problems recrudesce. They come back. Zombie-like. Both of these are of grave impact of import because they take functionality away. They mean that new development breaks things that used to work or previously fixed, or subtracts features from the user. So regression tests have this special significance, this special set of risks associated with them. If it's a user escape, meaning a defect makes its way to the user and is only found by the user, that's a regression defect. They're going to be very unhappy often because a feature they used to use is now broken. They were counting on being able to do X, been doing it for a while, perhaps with, their documents using a certain feature, and now it doesn't work. The new release of the software not only has not particularly delivered value, it's delivered negative value. It's taken away value that they used to have in hand. That's a grievous, consequence you've imposed on them. Secondly, though, these sort of regressions where defects resurface are shockingly common, right? Merge conflicts. You fix something previously, someone else has a stale version of it, and they've been modifying related code, right? They do a git push, they have to resolve a merge conflict, and they prefer their side of the code, which discards the bug fix, right? Or someone tried to fix, so maybe you fixed a problem before, unbeknownst to you, it caused another problem. Someone goes to fix that problem, and they do it by breaking the original problems and resurfacing that problem, right? We know about these sort of cycles you can get in where you squeeze the balloon here, it pops out there, squeeze it there, pops it back where you originally squeezed it. So regressions are very common, and companies, when they fix a defect, they generally create a regression test there's a test that confirms that defect is fixed, because that's just basic responsible software development. When you fix something, you make sure that it's fixed, and then you add that to your regression suite, and your regression suite is often testing that features still work, so that if your system is regressing, bugs have come back, features have stopped working, you catch it as soon as possible. And regression suites can grow to tens of thousands of tests, because you've got to guard yourself against reemergence of all these old bugs that used to be there. And so you're running these test suites against massive numbers of tests. Make sure none of those reemerge. But there's other types of tests as well. We divide between manual tests, which play a key role for things like exploratory testing, following your nose, looking for odd behavior and zeroing in, or for manual scripted testing, according to gherkins, perhaps, or very well-defined scripts. Then there's automated tests, and those can fall into UI-based tests that go through the user interface, which are often give a sense of user experience, but often break if the user interface evolves. Often they'll be slow because they have to operate through the UI. Maybe they have to use an emulator for a smartphone-based system, use the Android or Android emulator. The emulator is part of Xcode or what have you. So there's UI-based ones, and then there's what I call programmatic tests that are system tests. So here they call off to perhaps the business logic API and so on to accomplish tasks, to accomplish user meaningful tasks. That's what makes them system tests. But they call off directly instead of going through the UI. I mean, you go through the UI, it's going to call down to the business logic layer anyway. And you just, in your programmatic test, you instead of going through the UI, you call the business logic layer directly. And these tests often don't break nearly as frequently as the UI tests because UIs evolve. We split a screen into two different screens. We take a drop down and turn it into a button or whatever. Turn it from a hyperlink to a button, or we change things in the UI, break our tests that go through the UI, but you call off to the API for the business logic layer. It generally is going to evolve more quickly. I'm sorry, less quickly. So it's going to be more conserved. It's going to be slower. It's going to be more, slower in its evolution. And that buys us time it just means our tests break less. It's one of the reasons why tests generally speaking, manually testing something versus with automated tests, writing the automated test, keeping it maintained. The automated test may seem like it's so much less work because you can run it like that. But because of the amount of work involved in creating it and then keeping it up to date and fixing it as things change, UIs change, sometimes even APIs change, aspects of the design change. Generally, you put a lot more work into maintaining an automated test compared to a manual UI-based test. Yeah. Okay. Those are some comments on test types. So there's another distinction we can make too. Black box test. We're testing through the interface to the system, not with no privileged knowledge of its implementation, versus glass box tests. So I'm sorry, black box is what I said originally, and then glass box, where we know the implementation and we are, for example, seeking to systematically check every branch has been reached in there. And we'll go through and make sure that each branch has been reached, or that we've checked the conditions at different points in the code. That's glass box testing. I further talked about in this class tests that are based on test case design principles like coverage testing, and there are tests whose job in life is to achieve a certain type of coverage within the system, a certain contribution to coverage. Finally, and not to be distinguished with any of these, I'll note smoke tests, but the goal of smoke tests, as I've articulated them, is that the goal of a smoke test is not to find new defects per se, or to verify that a defect hasn't come back. The goal of a smoke test is to check if the current state of the system, the proposed, merge into main, or the just completed merge into main, if it's in a sane state. Can you go through the basic login and use of the system? Make sure that it's not so broken that if people pull it, they'll be harmed by it. They'll be unable to press forward their work. unable to continue their testing as a tester, unable to continue development because and do basic testing of this new feature they've implemented because the system is so broken that they can't continue their work. So a smoke test is designed to sense whether recent or imminent merges into main, the master, or into development, depending on your setup, are sane, are are problematic. To recognize and flag if they're problematic, so we can avoid getting that new code. So we can alert the folks who are responsible for that so that they can fix it. Okay. Time passes quickly. Tempus fugit. Are there any more questions here?
Really quick before anything closes, I want to check for my group's post-mortem. We put a cover page, which just brings it to like 9 pages total.
That's fine.
But like it's a cover page. Yeah, it's not actual content.
Yeah, that's
cool.
That's fine. I mean, if people wanted to put a team photo or, like put a figure or picture, like if I'm not going to be really picky about that. I just don't want to, I can't afford to read more than 8 pages per team to get the marks in the turnaround time that's required. And so but I'm not going to be like, I'm not going to, be really picky about those sort of things. Yeah, that's fine. Yeah, good. Other questions? Okay, folks. One observation I'll make. Been a really good course and a good class. I've really enjoyed working with you folks. And one thing I really liked about it is there's actually quite a lot of back and forth and discussion, despite my terrible problem with remembering people's names. Um, I did want to observe, though, that this session, this review session, is emblematic of that. Like, there's a lot of really good questions coming in, and I very much value your contribution to that. I think that's wonderful. It did mean that I didn't go through prepared slides. I will post those prepared slides imminently here. But if you're interested in getting what was not included, like to walk through the prepared slides, I think last year, and certainly I think the year before that, and both those have links in the Canvas site for the course, I put in links to those review sessions. You'll find me going through slides that emphasize major themes. So, like, if you want to, undertake the misfortune of hearing me go through those slides, you actually might find it a really helpful complement to this because I really hammer certain points, and the points I hammer then would be very similar to the points that I would hammer here had I the energy to continue. So I would refer anyone who who would like to hear that walk through the slides to one of those two sessions. I had the last year. I'm not sure the balance of questions and slides. I think it was some of each, but certainly the year before that, I think was mostly just push through the slides. So please be encouraged to refer to that. Okay. One yeah. Anyway, I think I'll close here. Thank you very much. I hope you find this useful. I will seek to post this very evening, and I'll post these slides post haste. Okay. Thanks very much. All the best with studying. Some of you may have exams for tomorrow. Hope those go well. I look forward to seeing teams tomorrow to go over ID5. And I look forward to seeing all of you in class and S320, S311.
Thank you, Professor.
On Tuesday. Thanks greatly. Take care there. Stay safe.